Good afternoon, one and all. This is the 30th lecture in ad hoc and sensor network. We were in module 5. So, yesterday we had started the second half of this module, that is next generation of wireless network, or which is also called as recent advances in wireless network. So, in this, there are mainly three topics. One was ultra wideband UWB, of radio communication. So there were different types, that is 802.11a, 802.11b, and comparison of them with ultra wideband. We have also seen the comparison of this narrowband and ultra wideband with Bluetooth and other communication paradigm. So ultra wideband we had finished yesterday. We have seen what are the issues, what are the differences of different types of communication with ultra wideband communication and all those things. Today, what we are going to start with, we are going to start with very important Wi-Fi system. Okay. And this is called wireless fidelity system. So if you see today's topic, the topic is mainly wireless fidelity system, and there is a service provider model for Wi-Fi system, though it is not clearly mentioned in the syllabus. In the syllabus, it is only mentioned wireless fidelity, but the service provider model is very much necessary for you to know, because you will be working, those who will be working in the field of Wi-Fi section. So there are four or five different models that have been proposed, or that are existing actually. So in that, the fifth model will be widely discussed with the diagram. And if time permits, we will start with the introduction part of optical wireless network. So this advanced or next generation network are having mainly three topics: ultra wideband, Wi-Fi, and optical wireless network. So we are in the second part. We will be seeing the second part today, that is Wi-Fi. And if time permits, we will see the introduction of the third type, that is the optical wireless network. And optical wireless network remaining part we will do in the next time whenever the lecture will be conducted. So let us see what is wireless fidelity system and what is service provider model. So wireless fidelity system is the high speed wireless LAN that was originally intended to extend the wired Ethernet in offices and wireless clients. So it is actually the wireless substitution of LAN. The coverage area and the ability to support high bit rates are the two major reasons behind the name Wi-Fi. So wireless, because we are not going to use any kind of physical wire for connectivity, and fidelity. So fidelity means good way of communication. And why it is called as fidelity? Because it was giving very high bit rate and with very less amount of drop and other thing. So these are the two advantages. That is, there is no wired connected, and there is high bit rate of communication possible through Wi-Fi. Though the 802.11b and 802.11a LAN standards, IEEE, they are actually Wi-Fi candidates, but conceptually, any high-speed wireless LAN protocol such as HyperLAN also can be used. So 802.11b, 802.11a, and HyperLAN all can be used for Wi-Fi. The main feature, it is given here in the second paragraph. So the integration of Wi-Fi hotspots, that is the wireless LAN, WLAN, or access points, which are also known as AP. So the integration of Wi-Fi hotspots, access points with wide area network, which is called as WAN, such as GSM, GPRS, all this provides an added advantage for the mobile nodes. So through this wireless feature or wireless fidelity, we can communicate between WLAN, Wi-Fi hotspot, GSM, GPRS. All these things can be integrated by using this technology, which is highly advantageous. Such an integrated system provides secure, reliable, and high-speed wireless connectivity. At the same time, we can get to know exactly the positioning of the network, where it is positioned, and how long it is stretched, what is the circumference up to which we can communicate, and all these little details regarding network we can come to know. A Wi-Fi network can be used to connect computers to each other, to the internet, and to the wired network. So it can be used as a interface between the internet and the wired network. Wi-Fi networks operate in the unlicensed 2.4 gigahertz and 5 gigahertz radio bands. So these are the two bands you should remember, with 802.11b and 802.11a. We have discussed all these two yesterday during the comparison with ultra wideband. So Wi-Fi networks are operating with unlicensed 2.4 gigahertz and 5 gigahertz radio bands. Please remember this, with a 802.11b or 802.11a protocol, or with products that contain both these bands. So dual band Wi-Fi it is in that case, that is 802.11a and 802.11b. Both together might be used in case of Wi-Fi, so they can provide an enriched network experience. So obviously at 02.11a and b, if they are both together and together they are providing the Wi-Fi, they will be giving a better response and enriched network experience. Wi-Fi systems are potential candidates for provisioning high-speed multimedia content delivery in areas such as indoor offices, airport lounges, and shopping malls. So whenever I'm saying multimedia and high-speed data delivery, in that case, voice communication, text communication, and mainly video communication comes in picture. So all these things can be very well and very perfectly transmitted by this Wi-Fi paradigm. So the Wi-Fi Alliance is a non-profit international association formed in 1999 to certify the interoperability between 802.11 based products in order to make the objectives of a Wi-Fi a reality. So there are many products which are available that are using the IEEE 802.11 protocol. It can be 802.11a or 11b. So all these products are put together so that this committee, which was established in the year 1999, so their effort is to compile all this different products. So it's a kind of a heterogeneous kind of a network, but they all are using Wi-Fi, and interoperability between all these devices are possible due to the Wi-Fi. The advantages of Wi-Fi systems are ease of use, so they can be very user friendly. High speed internet access, that is the main advantage of Wi-Fi. Low cost of operation and flexibility of reconfiguration. So this last four characteristics, that is ease of use, high speed internet access, low cost of operation, and flexibility of reconfiguration. These four things you should always remember while discussing the Wi-Fi. So these were the introduction of Wi-Fi system. Let us find out what is the service provider model for Wi-Fi system. So how different users and service providers they are connected. Okay, that is actually discussed in different service provider model. So the first is Wi-Fi microcarrier model. So in this model, the small business operations can be set up their own access points. So access point is a very important thing through which this Wi-Fi propagates. So in this model, that is the first Wi-Fi microcarrier model, small business operators can set up their own access points and maintain customer relations and billing with subscribers. An example of this category is a restaurant operating a small Wi-Fi system with a set of APs on its premises. Okay, so only one access points will be there, and billing will be there with the subscriber, and they are going to run a Wi-Fi for the users. There is a first, that is Wi-Fi micro carrier model. Very less number of users can be there in that case. Second is franchisee franchisor model. The model for Wi-Fi system is the franchisor company making an agreement with the franchisee. Okay, there is a restaurant which has an inbuilt Wi-Fi system for its internal purposes. So they provide Wi-Fi connectivity for a revenue sharing basis. So in that case, all the users they are sharing the revenue. Okay, so in the restaurant owner is actually taken the Wi-Fi, and he is providing this access to the persons who are coming to the restaurant, and both are paying for it together. Okay, so there is a revenue sharing occurring in case of this franchisee franchisor model. The external communication, access, network cost, back office software may be supplied and maintained by the franchisor. So whoever is the shop owner, whoever is purchasing the main AP module, that is access point module and all, he has to look after for all the hardware and back office software. Okay. Hence, the franchisor company can extend its service to the public. So either he can offer the service with price, with reduced price, or with no price. That is the prerogative of the franchisor. So here franchisor and franchisee both together, they are doing, uh, they are a part of this model, so they both are the stakeholders. Third thing, Wi-Fi carrier model. So this is a little bit for bigger area, and this is for more number of people. So first two models, Wi-Fi micro carrier and franchisee franchisor, they are not for huge number of people or huge number of people, public, who are going to use it. But the third module, that is a Wi-Fi carrier model. In this model, a particular company referred to as Wi-Fi carrier can own, deploy, and operate a number of Wi-Fi system-enabled access points. So we had known about SIFI, SIFI. Okay, so they were doing this kind of thing. So they were at the backbone of this Wi-Fi carrier model. So in this case, a particular company like SIFI, they are actually owning the Wi-Fi carrier. They're getting it from somebody through this line, but they're owning the carrier, they're deploying it, and they're operating a number of Wi-Fi enabled access points at public places. So all the maintenance, software, related hardware, all will be maintained by the company or Wi-Fi or the particular company who are owning the Wi-Fi carrier. So the subscribers can utilize the designated carriers network services in their coverage area based on acceptable billing models. So we were initially we were taking the service of SIFI, and we were using internet, and we were paying monthly around 500 to 1000 rupees depending on our data plan. Okay, so that was the most widely used model previously when mobile phone was not having internet this much. Okay, so all the data plans and everything was very costly at that time. Okay, so I myself, I used to pay for 1 GB data, I used to pay around 300 350 rupees once upon a time. Okay. So the Wi-Fi carrier model. So this was the model maybe around 20 years back. It was there. Okay, and after that the things evolved, and now you can see that every person is using a smartphone with a internet in this. Okay, Wi-Fi activated internet. Okay. So the fourth model is the Wi-Fi aggregator model. So as we are increasing the number of models, the user number of users are being more, and the bandwidth and all those things that we are going to get, the usage is getting more. So everything is going towards a higher thing as we are going from the micro carrier model towards aggregator model. So the aggregator model, the one, this model refers to abstract service providers which strikes wholesale partnership with the Wi-Fi operator. So somebody is there at the backbone. Okay, he is the sole proprietor of the whole Wi-Fi system, and but he is not coming at the front. So he is the back end. He is there at the back end, and he is having a partnership with the Wi-Fi carrier model private companies. So the model refers to an abstract service provider which strikes wholesale partnership with the Wi-Fi operators. Such aggregators mainly focus on two major things. So whenever the aggregator model is there, it is focusing on, first is reselling of the service provided by the Wi-Fi operators. So they are purchasing it and they are reselling it to another company who is using the Wi-Fi carrier model. So for the same bandwidth, the charge is getting escalated. So this Wi-Fi aggregator model, whoever are the company at the backside, they are purchasing it from government, and they are paying some value. But whenever they are giving this same bandwidth to some other person or spectrum to some other carrier user, other company, they are charging some more amount of money for that. So this is the way the charge is getting escalated little bit. So this model refers to abstract service provider which strikes wholesale partnership with Wi-Fi operators. Okay, and such aggregator mainly focus on two major things. First one is reselling. So through reselling, they're earning some money actually. So reselling of the service provided by the Wi-Fi operators. And number two, giving their subscribers access to a large number of networks. So this is very important. So first two service provider model was for very less number of people, maybe 10, 20, 30, not more than that. The Wi-Fi carrier model was actually serving hundreds of people, but this Wi-Fi aggregator model, it can serve thousands of people. And in this Wi-Fi aggregator model, there are two main points. One is reselling of the services, and second one is access given to large network with thousands of people in it. So advantage of this model are easy scale up, of network coverage, as the aggregator don't own the infrastructure, and hence by having more partnership, a service provider can increase the coverage area and customer base. So in this case, this aggregator model, it keeps on building with public. Okay, so more number of public joins to it, the network gets stronger. So this is the advantage of this model, that is easy scale up. That means giving connection, establishing connections from one person to another or one home to another home, this becomes easy. And as the aggregator is not owning the infrastructure, okay, because whoever is asking for the access, they have to pay for the infrastructure. But in this way, the whole network area is getting bigger. Number of people who are using this network is also getting bigger. So this is quite a large model, but this is not the final. The final model which we are using is the fifth model. So this model we will be discussing. So there are three slides which explains some properties of this model. So mainly service provider model, fifth type, the extended service provider model. This can be asked for a 5 to 10 marks question. In this case, you have to draw these three cells. So you can see that there are three cells, hexagonal cells, which are shown here. So this is the first cell with a base station at the center. Okay, and there are different mobile nodes. Mobile nodes means not mobile phone. Okay, so there are nodes which are moving. Okay, they can be mobile phone, they can be laptop. Okay, they can be some other iPod or something. And there is a second, another a hexagon or another cell at the center, there is a base station. This is another cell and there is a base station at the center. So BS stands for base station. And you can see the mobile nodes are having name A, B, E, D, C, and all. This is having K. Now there is a new type of symbol you can find here, which is called as a Wi-Fi access point. Okay. So what is Wi-Fi access point? This is a very important thing. So Wi-Fi access points are the points through which the Wi-Fi can be accessed. So if you can check this link, okay, so this link is actually the connection between the Wi-Fi source and the Wi-Fi receiver. So whoever is accessing Wi-Fi, they can be here or they can be here. They will be able to access Wi-Fi. Okay, so this is a new symbol which is a Wi-Fi access point. This is a hut kind of symbol, and this is a if this K wants to send a message to BS, it can do that through the Wi-Fi access point. So here from K, the message is going to Wi-Fi access point, and Wi-Fi access point is connecting with base station. So that is possible. And this base stations are also being called as switching center or gateways. So you can check here. So there's a switching center or gateways. So name is written once, but this is connected to this base station. The switching center is connected to this base station, and this switching center is connected to this base station. So only one switching center and gateway is there, which is connected to base station. All the base stations are generally situated at the center of the hexagons. So what are different kinds of things we can find here in this diagram, which is a special scenario of Wi-Fi system. So first, there are base stations in every cell at the center. Base stations are surrounded by various mobile nodes. So one is base station, another is mobile nodes. Two types of elements we are finding here. Third one is Wi-Fi access points, this hut kind of thing. Okay, so these are Wi-Fi access points. There's a third type of element in the image, and fourth is the central thing, that is a switching center and gateways. So this whole, all this hexagons, if they want to communicate with the external world and all, then they have to go through the switching center and gateways. So there are mainly four things that you have to explain in this case. Among them, base station and mobile nodes are very easily known to us because we have discussed it many a times. Wi-Fi access points and switching center and gateway, these are the two new models or elements that you will find here. So all these things are put in synergy. Synergy means all these things are put in together, and the advantages of all this, that is advantage of gateway, switching center, Wi-Fi point, all this, the good points of all these things are put together, and this is a very strong special scenario extended service provider model where the seamless connectivity is maintained between all the base stations, between all the mobile nodes, and between every access point, and a total very big area fully covered by Wi-Fi facility can be generated by this fifth model or fifth type of service provider model, which is called as extended service provider model. So let us see that the synergistic operation. Synergistic means when the positive points of everything, every element is getting added together to form a bigger and lot better system that is called as synergy. The synergistic operation of Wi-Fi systems with existing cellular system, especially with the 3G system, can increase the profits of cellular operator. So we can remember that before 20 years, the phone was only phone. It was not having any internet. So in that case, we were using only the uh, Wi-Fi, not Wi-Fi, only the cellular module of that. So we were only transferring text and we are only talking or receiving calls. Okay. Later on, nowadays, this synergistic operation that Wi-Fi has been combined with that. So Wi-Fi is combined with all the 3G system, and now Wi-Fi, internet, and phone, they have become together. So mobile phone and internet, they are actually the synergy, and they has increased the profits for the cellular operator. Not only that, they have added a lot of ease and advantage in the user's life. That is more important. And user is ready to pay any amount now for the service that they are using. So this can even lead to reduction in deployment cost of 3G systems, because the cost is getting shared, because the cost is getting now shared between cellular and Wi-Fi both. Okay. The widespread deployment of Wi-Fi system can be considered as complementing the 3G system. So Wi-Fi and 3G, they are complementary. That is the data and voice. Also, the availability of wireless systems equipped with Wi-Fi and cellular interfaces encourages the possibility of switching to the Wi-Fi system whenever the access point is detected. So these are the access points, Wi-Fi access points. So whenever the access point is detected, the data transmission can take place not only through base station but through access point also. So sometime the C, if it wants to talk to D, so either it can do it through the base station or it can do it through the this access point, that is a Wi-Fi access point. That's why it is said that the availability of wireless devices equipped with Wi-Fi and cellular interfaces. These are two things. One is cellular interface, means this is the mobile, that is the voice and voice messages or text kind of thing, whatever was there previously. There is a SMS and voice, and now we are adding the Wi-Fi with it. So if this C wants to send the message to D, either it can do through the base station or it can do through the Wi-Fi. So this is what is said, that the availability of wireless devices equipped with Wi-Fi and cellular interfaces encourages the possibility of switching to the Wi-Fi systems whenever an access point is detected, that is AP is detected. So this is Wi-Fi access point. So base stations are not having internet facility. Internet facility is accessed from this access points, that is the Wi-Fi access points. Now here the same diagram is there, only I have mentioned this mobile nodes with the names. So it is previous diagram, it was not shown, but now I have mentioned this name as A. So names are kept same, only I have mentioned it here. So this is B, this is C mobile node, this is D mobile node, this is E mobile node, and this is K mobile node. So some features of this network is explained by means of some name of the mobile nodes. That's why I have named it. So there are three base stations. There is one switching center or gateway, and there are three Wi-Fi access points. So let us see what are the different features of this service provider model. That is the fifth type of extended service provider model. It is saying that vertical handoff. So what is vertical handoff? It is the handoff promoted performed across the networks which are operating at widely varying coverage regions. For example, the handoff performed between WLAN and WAN. Okay, so wireless LAN and wireless area network. So wireless area network is a Wi-Fi kind of a network, and wireless LAN is a uh, wireless type of local area network. So the circumference of WAN is very big, circumference of WLAN is smaller comparatively. Okay. So whenever this kind of handoff is to happen, that is from wireless WAN to WLAN, that means from a bigger area, when the data or the message wants to come to us within a smaller area. So WLAN to WAN or WAN to LAN. Whenever this kind of switching takes place, this is actually called as vertical handoff. So this vertical handoff can be used to switch back to the wide area cellular network as and when necessary in such a cases. So this access points, Wi-Fi access points, they are actually a part of WAN, and this base stations BS, they are actually part of the smaller cellular kind of network. So these are actually telephone networks or mobile phone networks, BS, and previously it was separate, so now all they have become merged. Okay, so and these are the small points which are called as Wi-Fi access points. So vertical handoff means from BS to Wi-Fi access points, from Wi-Fi access points to BS, there should be seamless connectivity, there should be seamless handoff. So this handoff can be used to switch back to the wide area cellular network as and when necessary in such cases. Extended service provider model envisions the provisioning of Wi-Fi services as an extension to the existing services provided by the cellular network operator. So whenever, why is it called extended service provider model? In this extended service provider model, provisioning of Wi-Fi services as an extension to the existing cellular phone services is there. So what is extension? Extension is nothing but previously only voice and uh, text message. So these were the only thing. Okay, this was not extended version. What is extended? Whenever the same tower are used with obviously added hardware, when the same towers are used for internet related facilities, then we are calling it as a extended. So whatever we are using nowadays is extended version of service provider model. So this is what is said. Extended service provider model envisions the provisioning of Wi-Fi services as an extension to the existing cellular network operation. Illustration of such model is already shown in the left side. Here the users can access information and data through either the Wi-Fi access point or through the 3G base station. So this is the flexibility which is offered. So this C, it can get data through this Wi-Fi access point, okay, or this can get data through this base station. So base station and Wi-Fi access points, they can be used interchangeably. And nowadays, this Wi-Fi access points and base station, they have merged. So they have become one entity at the kept at the center of the cellular cell. Okay, that is there. So last thing, here the users can access information and data through either Wi-Fi access point or through the 3G base station. Referring to this figure, so this figure at the left, node C can communicate directly with base station. So you can see here this node C, and there is a communication channel. It can directly communication with base station for making a call to the destination E. So we have seen this in case of cellular, always a base station is coming in between. So if this C wants to send data to E, first C sends data to base station and base station relays it to E. That is what says, referring to the figure, node C can communicate directly with base station for making a call to the destination E, whereas node K can communicate with the base station through the nearest Wi-Fi. So this K is not able to talk to base station directly, whereas K is talking to the access point, which is a Wi-Fi access point, and this Wi-Fi access point is talking to the base station. Why cannot K talk to base station directly? Because K is outside the hexagon of this base station. So K is not within the cell, but this wireless access point is within the cell, and K is within the range of this wireless access point. So this scenario you have to understand, that is, this is the cell K, or this is a mobile node K, which is outside the cell of this base station hexagonal area. Okay, so this K is outside the hexagonal area, but K is within the circular area of this access point. So in that case, K can directly talk to this Wi-Fi access point very easily. Okay, and this Wi-Fi access point is existing within the cell of the base station BS. So this K talks to this BS via the Wi-Fi access point. So in this case, the data transmission or video, voice, all this transmission from this mobile to base station happens by means of this Wi-Fi access point. So this is a very important case. So in this case, node K, so previous case it was C was talking to E through base station. It was only cellular kind of operation. But in this case, for the node K, K is talking to base station via the Wi-Fi access point. So node K can communicate to the base station through the nearest Wi-Fi access point. AP stands for access point. This choice of selection can be based on network availability, cost of access, bandwidth availability, and specific user requirements. So these are some features, or these are some criteria based on which we can set the connection. So this choice of selection, that means one mobile node will connect to the base station or connect to another node through which intermediate nodes or through which intermediate access points. They actually depend on network availability, cost of access, bandwidth availability, and specific user requirement. It may be possible that the communication between K to Wi-Fi, so this communication may be charging more compared to C talking to BS. Whenever C is talking to BS, this might be charging 50 paisa per minute, but this K is talking to wireless access point, this might be charging to 1 rupee per minute. It is possible because this is a different type of communication that is between K and Wi-Fi access point and between C and base station. So that is what they are saying. The choice of selection, that means who will connect to whom for final destination. So here final destination is base station for K. For C the final destination is E. So who is going to communicate to whom? That choice of selection can be based on the network availability, the cost of access, the bandwidth availability, and the specific user requirement. Such a system requires placement of access points at places such as crowded traffic junctions. So here you can check, this is a access point, network access point, which is kept exactly at the center of all these three cells. So that all these three cells, most crowded point is this one. So this is at the center. Whereas this thing is away from all these three cells. Okay, and this access point is within one cell. Okay. Likewise, so such a system requires placement of AP at places such as crowded traffic junction, public places, and railway stations. So such kind of Wi-Fi access points, they have to kept in the central position, and they have to be kept in such a position where most of the people can stand and access the access point. The presence of multiple service providers trying to use this model would result in managed utilization of spectrum in the bands assigned for 802.11. So it is understood that they are using 802.11 bandwidth for all this data transmission and all. Okay, and there will be multiple service providers because in this case base station as well as this Wi-Fi access points both are being used as a data center for data relaying and data accessing. So these are the three slides, same diagram, but lot of features regarding the extended service provider model is explained. And why it is called extended service provider model? It is given here. So in this case, extended service provider model envisions the provisioning of Wi-Fi services as an extension to the existing service provided by the cellular network. So as a cellular network is providing the service of Wi-Fi, this thing is a extended service. So this completes actually the Wi-Fi module. And now we will see the introduction for optical wireless network. So optical wireless communication enables the communication using infrared light wave operating at frequencies well beyond visible spectrum for high data rate and local communication. So these are the two main things we have to remember, three main things we have to remember. That is, optical wireless network is using generally infrared, and which is not visible for us, and this is actually for high data rate and local communication. So there's the four things you have to remember. So optical wireless network using infrared, which is not visible, two things for remembering, and it is using high data rate, and this is mainly for the local communication. So for very far kind of communication, this optical wireless network might not be used. Optical wireless communication technology exhibits a number of properties that makes it a suitable alternative for indoor RF communication. So within a indoor area for RF communication, this is a very suitable candidate, that is optical wireless network. Advantages. So this can be asked as a short question. The advantages of optical wireless communication include significantly less interference due to its lack of penetration through wall positioning of spectrum at a completely unregulated and unlicensed band, increased security, and high data rate. So these are the features we must remember for optical wireless network. So advantages of optical wireless network communication include significantly less interference due to its lack of penetration through walls. So in one room, if we are setting a optical network, mostly within that room only we can communicate from the transmitter of the network, because this kind of infrared which are invisible, they cannot penetrate the wall and go to the other room. So this is restricted within the opaque wall of the room. So this is the advantage, because in that case, if you are having a another optical network in the room at side, that communication and optical network communication of this room, they will not be interfering with each other. So though this kind of communication cannot be extended to huge area, but within the small area, they will work very fine without any kind of interference. So every thing is having its usage, every type of or every modality of communication, they are having their own advantage. So the advantage here is they cannot penetrate through the wall. In that case, the interference in this case is less. Positioning of spectrum at a completely unregulated and unlicensed band. So whatever frequency band they're using, that is not regulated by any body, and that is actually using an unlicensed band. So we are not supposed to pay anything to anybody if we are using optical wireless network. Otherwise, purchasing the bandwidth, purchasing the spectrum is to be is a very costly affair, and we have to spend quite a lot of money for purchasing the bandwidth. But for optical wireless network, it's a completely unregulated and unlicensed band. So two very big advantages. First one is due to its lack of penetration power. It doesn't interfere with the other rooms optical network. Very big advantage. That is, interference is very less. And second thing is, this optical wireless network uses range, which is in a completely unregulated and unlicensed band. Security increases because it is not interfering with other rooms network, so it is confined within a certain area. It cannot be accessed from outside the room if all the rooms are closed. So hence the security is more, and data rate is very high because frequency of optical wireless network is optical signal, whichever is used, is very high. So all are very advantageous. That is, due to lack of penetration, it cannot go to the other room, and penetration is interference is less. Second is, it is unregulated or unlicensed band, so we won't have to pay anything to anybody for using this bandwidth. Then security is increased because it cannot penetrate and go to the other room. It cannot be spread among a wide area. Okay, so it is confined to a smaller area. That's why spread is less, means security is less. And fourth thing is, data rate is very high because frequency range of optical is a lot higher than Wi-Fi. So these are four very big advantages of optical wireless network. Optical wireless technology promises broadband data delivery, that means high data rate. So broadband data delivery at short ranges. So range is small, but data rate is very high. In a point to multi-point LAN or point to point medium distance optical link. So this is again important thing. So point to multi-point and point to point medium distance optical link. So for very long distance, this kind of thing cannot be used. Optical wireless transmission is classified into short range communication and long range communication systems. Long range communication systems are mainly used for outdoor point to point optical links, and short range systems are used to indoor and outdoor applications. So whenever I am saying optical long range communication, obviously we need some repeater stations in between. So there are some certain kind of amplifiers, there are certain kinds of intermediate nodes or repeater nodes that we have to use in case of long range optical communications. Unlike the long haul network in fiber based optical networks, the long range optical wireless systems can operate over a distance of hundreds of meters. Okay, so whenever I am saying long range, hundreds of meter is very long range for this optical communication thing. So that's why it is saying the long range optical wireless systems can operate over a distance of hundreds of meters only. That means 400, 500, 600, maximum 900 meters. So not even 1000. Short range systems operate over a distance of few meters, so 5 meter, 10 meters and all. So how much is long range? So long range is in hundreds, and short range is in tens. That we have to understand. So short range means around 100-meter maximum. Long range means about around 1 kilometer maximum. That is for the range of optical wireless network. With the ever-growing demand for broadband wireless connectivity, the utilization of RF spectrum is a bottleneck. That is the main problem due to the spectrum congestion, license requirement, and usable unsuitability of certain bands of broadband application. So ever-growing demand of broadband wireless connectivity. That means everybody is now want broadband wireless connectivity with optical. So because the RF spectrum is a creating certain problems. Okay, so broadband through RF, they're creating certain problems. What are the problems? Spectrum congestion, licensing requirements, unsuitability of certain bands for broadband applications. So whenever I am trying to connect broadband with RF, they are having licensing issues, they are having congestion issues, and they are having compatibility issues. So the same broadband, if you're using with optical wireless network, in that case, all this congestion and licensing and unsuitability, all those issues are not there. So these are advantages of optical wireless link over RF wireless link. What is that? That is given in the last paragraph. There is optical wireless link are less having less congestion. They are not having any licensing requirement, and they are actually compatible for different bands of broadband applications. Where RF is having a licensing issues, a compatibility issue, and congestion issue. So these are the introduction of optical wireless network. So in the next lecture,